Today's speaker is Mr. Barry Sheward. He joins us today. He brings a wealth of experience in cloud computing, and he's going to talk to us about. Well, actually, I'm going to pitch it over to Barry. I think he's going to describe it best to us. He's an industry member, and he's well, I won't do it justice. Barry, please.
Thank you, Peter. Can everyone online see the webcast okay?
Anyone?
Rich?
I can see it in Oklahoma City.
Excellent, thank you. All right, so I'm here to discuss migrating to the cloud. Move straight on to the first slide. So basically, I started working with virtualization solutions back in 2007. The part of Lockheed Martin that I worked for as a lab environment that used to bring in lots of third-party applications for evaluation. That we would test them and decide which programs they would be applicable to. And originally, all this was done on physical hardware. But one of the technologies that we brought in to evaluate was VMware's Virtual Center at the time. And we played with it, we liked it, we started using it as a virtualization platform in order to perform our other duties, that is, installing these applications, these other applications for evaluation. And being a bunch of engineers, we realized that there were specific problems and things that we needed to work around. The kind of problems that Gartner would later say are issues with virtualization, things like sprawl, things like the fact that systems administrators would not only have to manage the original sets of systems, but now they had to learn about a virtualization platform to manage. So based on these issues, we started to develop some scripts and solutions to some of the problems.
Please mute your phone.
And the solutions kind of grew into a self-service interface, which we used in our own lab. It then became something that we would be able to offer on as a value add on programs. And around the time that the government started to look at cloud computing, we realized that we actually had a solution that would meet the requirements for cloud computing. So based on that experience, we could be talking today about how we've migrated customers to the cloud, number of different perspectives. And so what I'm going to do is the first part of the presentation is really going to be discussing how we evaluate in preparation for moving to a cloud solution or even a virtualization platform. And the latter part of the presentation is really going to be talking about some of the lessons learned and issues that we've encountered while we've been doing this work. So that's me. I'm LM Fellow at Lockheed Martin. I'm responsible for the cloud solutions out of our Insight lab in Gaithersburg. My career basically started with Computer Associates many years ago. I was working on enterprise IT solutions. I then worked for a small startup that worked on cybersecurity solutions, and then went to TrueSecure, which became CyberTrust. Again, working on cybersecurity solutions, and from there went to Lockheed Martin working on cloud solutions. So pretty much my whole career has been ensuring that IT assets are available to the customers that need them, whether it be from an enterprise IT availability perspective or a cybersecurity availability perspective to cloud provisioning. It's all about getting the resources to the applications. So just a short description of cloud terminology. There's an awful lot of confusion in the market. And one of the things we've noticed is that there's so many different combinations and permutations with cloud that you can pretty much say anything you like and it will be right according to one of the classifications. So the cloud characteristics basically are the critical things. In order to be a cloud, you must have on-demand self-service, which is basically Nowadays, a website where you can go into in order to provision your own resources. You don't need to call anyone up on the phone and have them do it for you. Network access from anywhere. Resource pooling. So basically you have groups of compute resources where you can build your environment. And those resources may be scattered around the country or even around the globe. You don't necessarily know where they are. The NIST definition there is slightly different from, I think, customers' expectations. And we find that working with federal government customers, a lot of them really do want to know where their assets are. And we'll go into a bit more detail as to the reasons why later. And rapid elasticity, not just scale out, but also scale back. For example, around tax time, a lot of websites get hit in order to pull tax information. Just after tax time, the load on those servers goes down. You don't want to be paying for services you're not using, and hence elasticity in both directions. And then finally, measured service, the pay for what you use. And there's some interesting concepts in industry that enable you to further optimize what you pay in terms of the compute resources that you use. Delivery models are interesting. You've got your infrastructure as a service, which is basically where you get a virtual machine, your platform as a service, which falls into two categories. The first category tends to be the API type platform as a service, where the PaaS vendor will give you an infrastructure on which you write your application, and they will run it for you. They handle load balancing, scalability for you, and there's an awful lot of things you don't need to worry about. There are issues with adopting that particular approach of platform as a service. We'll come to those in the lessons learned section. The other part of platform as a service is managed infrastructure as a service. So that's where a cloud vendor will, for example, install Oracle for you. They won't give you access to the virtual machine, but they will give you access to the Oracle instance, so you can create your database, you can put your data in it. It's more managed infrastructure as a service. There's still issues in terms of scalability that need to be managed at an infrastructure level. And then finally, software as a service, typically well known to anyone that's got Gmail or Yahoo Mail accounts. The cloud service provider basically gives you the software, very highly scalable, supports millions of users, because effectively it's just one application. So as you look at the different delivery models, you get a lot more flexibility at the infrastructure level than you do at the platform or the software, but it tends to cost more. With Gmail, you don't have the same amount of flexibility. There's not a lot you can do with your Gmail, but on the other hand, it's really cheap, like free. So different delivery models have different costs. And then finally, in terms of deployment models, we've got your public clouds, community clouds, which is a kind of special case of a public cloud, all the way to private clouds, which are installed within a customer's firewall. And then on the right-hand side, you can see hybrid, which is a combination of those.
Barry, do you take questions?
Yes, sure. Fire away.
Do you have any sense of which is most popular or becoming most popular, maybe really popular, private, other kind?
So I think typically people are looking initially at private infrastructure as a service clouds. And the reason for that is that it's not so different from the traditional data center, right? You've got your own resources, they're in a room that you can see, you can put your hands around it, your IT staff still manages it. What you've effectively done by moving it into a private infrastructure as a service cloud is put a self-service interface in front so your users can get access to the resources they need without going through the IT department. We are seeing some more progressive agencies within the federal government moving to public cloud and platform as a service. For example, JPL, NASA JPL is a great example. They've embraced public platform as a service, developed applications that run on Microsoft Azure and basically it's the space data that's a public asset anyway, so they don't have the same kind of security concerns as many of the government agencies do. So it's nice and easy for them to put their data out there. The risks are much lower.
So Barry, another question. How many do you see that are viable public cloud vendors out there selling the service?
At the moment, there's a few. Obvious names are Amazon. I think Google's making inroads. Microsoft as well. Rackspace, Terramark. Those are the big ones. But there's a number of other niche players.
So is there real competition as far as cost of service?
Absolutely. Absolutely. Not just in terms of cost of service, but also in terms of performance. HP, for example, has got a cloud that I believe one review that I read said that overall the HP cloud was a consistently good offering for specific use cases, specific application workloads. It could be that the Google cloud would be a better fit, or the Amazon cloud would be a better fit. And that comes back to what I said earlier about the cloud terminology. There's so many offerings and permutations of all this. There's almost anything I could say would be right according to one of them.
So it really would be difficult for federal government organization to try to really research all of them,
right?
Determine which one most beneficial.
And quite honestly, I would say to that don't bother, let someone else do it for you, right? There's a number of vendors at the moment that are coming out with cloud broker solutions, right? Lockheed Martin has one, for example. And the whole point of those solutions is that they will look at all these different clouds, look at your use cases and say, you know what, you ought to create your virtual machine in this particular place. And that way someone else is doing the work for you and you can just take the benefit. And so I saw a question pop up saying, are the slide deck available? And I believe they are, but I don't know where. John, did they get posted?
They will be available.
Okay. So why move to the cloud? And I'll try and speed up a little bit. There we are. 5 years ago, if you ask people why they're interested in moving to the cloud, the answer would be because we've been told to. Right? Vivek Kundra and the cloud first. We've been told we need to. Can you please help us? A lot more people are more aware of what's going on with the cloud. A few years ago, you said, why would you move to the cloud? People say cost is going to be cheaper. I don't necessarily believe that's the case. Cover that in just a second. But agility is definitely the right answer. The reason for moving to the cloud is agility, and I think most people are picking that up. The 20% that still say that cost is the primary motivator, it depends on your use case. I don't know people planning their vacations. I don't know if anyone sat here and thought, I'm going on vacation, should I buy or rent a car for the 2 weeks I'm on vacation? Right? It's a no-brainer, you rent it. I did some calculations on my way here. I would really like a Tesla, right? They're about $62,000. If I were to rent a car, $40 a day, it would actually cost me about 4 years, just over 4 years, to pay for the Tesla. And with cloud, it's very much the same situation, right? If you have a consistent workload that you're going to be doing all the time, and you know it's never going to change, it may be cheaper to have it in-house, right? But the fact is, you've spent your capital dollars on the equipment, it's on your balance sheet, and if something happens, and this is where the agility comes in, if something happens and your application needs to move somewhere else, you've got all that hardware sitting around unused. Whereas if you rent it, it's an operational expense, right? The definition of operational expense is a cost of doing business. I think IT is the cost of doing business. It's not the business value itself. And we've seen cases where companies like Zingna is a well-known one. They started off using cloud. As soon as they realized what their baseline of utilization was, they bought that many servers, brought that baseline in-house, and then they only use the cloud for peaks over and above that baseline. And that's the optimum use of the cloud. Despite the fact that the Amazons and the Googles of the world can purchase servers and rack and stack them way cheaper than anyone else, they still have to put an overhead on top. And that overhead is something you're going to be paying. So, again, agility is the answer for moving to the cloud.
Just a question, just in terms of what you were saying there, the one thing that strikes me in the process is in terms of those decisions, that the one thing I think that's, at least I'm not hearing in the equation, is the shareability of data with other users that are outside of your purview as far as the work that you're doing. So, I mean, that's another part of the decision in terms of, yes, economically, I've got a peak, so therefore I want the cloud. But in reality, is there going to be times that you need the cloud for participation with a broader audience outside of your domain?
And very specifically, that's an application-specific use case, right? So, for example, the NASA JPL example, they had data that they wanted to get out. So putting it on the cloud was a no-brainer. What we're going to move to very shortly is looking at the different applications and what we need to do in order to determine, does it make sense to move this to the cloud? So,
but do you have a definition of agility? Because when I look at that and I think about finance center or agriculture or whatever, they pretty much have a mission that's private cloud. Somebody else might be wanting to use the agility of like JPL, where they have a massive amount of stuff. So, a target might get into social media and want to do that kind of stuff. So, people like Gartner or yourself or somebody broke it down, agility into more than just, hardware in and out, classic IT stuff.
I guess, and this is a off the top of my head on the spot answer, agility would be only having to pay for what you need at that moment. Right? That is, if my needs rapidly increase tomorrow, right, then I only need to pay for tomorrow for that increase in capacity, and the day after, if the requirements go back to their original level, so do my costs come down.
So in the public sector, where you've got a much more staid acquisition process, you may not be able to react as quickly.
Right. And, most large organizations, there's a procurement process. You fill out forms, procurement gets involved, they talk to multiple vendors. It can take 6 months to get a box from someone saying, I really need one to run this application, to having it racked and stacked and ready to go in the data center. And that's what we mean by agility. After 6 months, that application may be irrelevant. You may have hardware in there that you don't actually need anymore. And the fact is, it's a capex cost. It's going to be on your balance sheet for the next few years. Whereas you could do the same thing with cloud, have the virtual resources available to you that day, and if the business requirements change, then you're not paying for them the day after. Does that answer your question? Yeah. So, a little bit about the path to cloud. Typically, we've seen organizations move from a traditional data center, physical, bare metal hardware running applications, to a virtual data center. Virtualization, I think, has been the catalyst for cloud computing. What we typically see is that in a traditional data center, an application needs to be provisioned. People will order a specific set of hardware. It might have specific components within it. It'll be linked to specific sets of storage. Everything is kind of special case. And there's zero abstraction as well. With a virtual data center, it is possible to accommodate special cases. So, for example, if you have a virtual machine that you know is running on a particular physical machine, you could plug a USB drive into it or some other USB device, or connect fiber channel disks to that virtual machine. So special cases are possible, but there is the abstraction where virtual machines can move from physical machine to physical machine as the needs of the data center change. With a cloud data center, it's all about self-service provisioning, and usually special cases aren't accommodated. You can't say, I really need this USB drive, or I really need this disk connected. A lot more restrictions. On the other hand, again, costs can be considerably lower in a cloud data center, depending on use case. So the interesting thing about cloud migration, what users typically see are that they're going to get on-demand self-service, flexible usage, access from anywhere, and pay per drink. There's an awful lot of things to consider below the waterline, so to speak. Security, particularly in public clouds and community clouds. How the solution ties in with the in-house processes, for example, financial asset management. Ensuring that you're compliant with security. So if you're in an environment where virtual machines can move from physical machine to physical machine, are there going to be compliance issues with performing those operations? Vendor lock-in, we already spoke briefly about the platform as a service API type model, but if you write your application to run on a particular API platform as a service, you're not going to be able to move it to another one. There's some lock-in there. So a number of things that you need to look into when you're considering cloud migration. It all basically, though, starts with application assessment. And the great news is that you don't need to be a cloud expert in order to perform this, right? Anyone with a business knowledge of the organization can do it. And effectively, what we're doing by looking at the applications is building a set of requirements that we can then give to the virtualization or cloud people to say, for this particular application, this is what we need. And obviously, just like most other IT projects, the better we get the requirements, the more likelihood of success we're going to have when we actually come to do the migration. So at the top level, basically try and classify the application. And there's a number of buckets here. These are, for example, we might find some better examples, but we often find that you've got your legacy applications, the types that run on Solaris, Spark, or HPUX, or AIX, or AS400, non-Windows and Intel, or non-Linux and Intel type applications. And the interesting thing about these applications, they're very difficult to virtualize, to move on to commodity x86 hardware, to a virtualization environment, or to move to the cloud. But if you can do it, often it can drastically reduce your costs. You're not paying a single vendor for hardware upgrades that have got to be of a certain type, but a lot of work involved in legacy. Enterprise is the mission-critical application. For many organizations, email is now considered a critical mission application. How many agencies would no longer function if their email system went down? Very high service level agreement requirements, very high resource requirements, but there's often some things about enterprise, like you could have the SLAs change depending on the time of day, right? If you're 9 till 5, you might want 5 nines. Outside of that, you might be prepared to accept 3 nines availability. So that there's things that we can do there in order to optimize the process. And I've worked with some organizations that have said, you know what, it's just safer to say that everything needs to be FISMA high, or everything needs to be 5 nines. But classifying the application correctly means that you can dramatically save costs. Because if you're trying to do everything at a FISMA high level, or trying to make it 5 nines available, costs are going to be astronomical. In terms of big data, large volumes of complex processing, but often you find with big data it's batch process type work. So with big data applications, could you actually run them outside of normal business hours? Share hardware, that kind of thing. Web applications tend to need to be 24/7, might need to be incredibly elastic, and you need to be able to roll out applications seamlessly, so without a lot of downtime. And then finally, there's desktop applications. Virtual desktop, basically being able to put applications available virtually on someone's desktop. I'm not going to go too much into VDI solutions. I tend to concentrate more on the enterprise application side of things. So obviously the critical thing is understand the business impact. So if you're new to the migration process, low impact applications could be migrated first. Things like your expenses system, where someone's got a month to get their expenses reports in, and if there's a hiccup in the process of doing the migration, then if the application's unavailable for a week or 2 weeks maybe, it's not going to have a critical initial impact. Considerably different from, for example, if your website goes down. If it's unavailable for a couple of weeks, it can cost you millions. Companies like Sony had a massive impact on their reputation when their PlayStation Network was unavailable for a few weeks. And Amazon as well, they've had outages. It's impacted their business. So understanding the application requirements. In terms of security, do you need two-factor authentication? What is the level of the data that needs to be applied? Are the applications old? So is it very difficult to secure them, and do we need to build additional wrappers around them to help reduce the risk? What is the uptime in terms of availability? Does this application need to be 24/7 or can it be a 9 to 5? And obviously, selecting the right approach changes the cost dramatically. Some applications are very sensitive to latency, so and also users are very sensitive to latency. So when you click on a website, you don't want to have to wait 30 seconds for it to reload. And kind of related to latency is bandwidth. If you're going to be moving a lot of data around, ideally you want the distances to travel to be as short as possible. There may be very specific API requirements. So we've seen applications in the past that do things with the operating system that they're not supposed to. So moving them, for example, from Windows 7 to Windows 2012 might be a major problem because of API restrictions. Applications may need specific hardware. So, for example, some applications nowadays make use of graphic processing units in order to do a whole bunch of number crunching. And then finally, geography. So if you have an application that's connected to a sensor that measures weather or seismic activity, you're not going to want to increase the length of the cable going to the virtualization environment or private cloud. That virtual machine has got to be physically located close to the equipment. And then finally, in terms of data requirements, you've got your a lot of legal and regulatory requirements. For example, if you're storing data which is about European Union citizens, you're not allowed to move that data outside of the European Union. So although it's great to think that you could do disaster recovery and move data sets, say, from the US to Europe, vice versa, that for legal reasons may not be something to do. And then also you've got things like your test, dev, and production environments. You're going to want to make sure that your data is limited to the environment that it should be in. I know a lot of applications during development, they like to take the production data just to make sure that the application can work at scale and with specific data, but developers shouldn't have access to certain pieces of data. So although with cloud it's very easy to move disks from one environment to another, sometimes there's reasons why that should not be done.
Barry, I have a quick question, if I may.
Sure.
Earlier, I picked up that you said that there were cases where the claim of cost savings with respect to some cloud solutions, just while the claim is not necessarily realized. When you're doing this assessment, if you're looking at, for instance, a commodity service, and you talked about, and I'll use this as a for instance, but it's probably not the best example, of email.
Right.
And you're saying it's a mission critical thing. It could have high throughput, and that might drive cost given the provider, right? Is there, for those commodity services, you would expect, the policies and directives are saying take email, put it on the web. Is there a cost curve, basically, as you're doing these assessments that say, well, it maybe that solid utility that is mission critical isn't going to work for us? Are you finding any of those commodity services are kind of hitting the wall on cost or the promise of cost savings?
Not hitting the wall. I think we still haven't seen as far as we can take this. And a lot of it comes down to risk and what agencies are willing to accept. So, for example, in-house, you've got an email service set up, right? You're paying it, you're running it. One approach might be move that to an infrastructure service as a service cloud, right? AWS, for an example, right? Do a great job of running infrastructure as a service. And what you're going to be paying there is maybe you need to increase the number of servers occasionally to meet load, and Amazon will help you automatically scale. So you'll get some benefits there. Email, though, is a really great example where, because it's so well understood, there are now offerings in the software as a service space. And when we looked at the first slide and I said, you've got your, on the one hand, as you move from infrastructure up to software as a service, you decrease your costs, but you also decrease your flexibility. With email, that's not such a big deal. Right? Most people are happy to say, you know what, I've got Outlook, I'm happy with what it offers, I don't need a whole lot of tweaks. So Microsoft has said, okay, well, we will offer Outlook as a software as a service solution. Because of the way that software as a service has a much greater efficiency in terms of its utilization, rather than needing 5 virtual machines per customer at the infrastructure level, you can run hundreds of customers on a single virtual machine at the software as a service level. So there's economies of scale that we're still moving towards as companies are accepting that they don't need to run everything internal themselves.
Gotcha. And really, if I could distill that down to its essence, you're saying that if you have a business need that is bursty, you're going to see that the surges by utilization during time frames, commodity or not, those tend to be the ones that are going to drive the best costs, absolute benefits, absolutely. And if you design it right, the best agility benefits.
Right.
Gotcha. Okay. Thank you.
And it is always a trade-off. If you need to design the rules correctly, I've seen situations where applications have been designed to automatically scale, but you find situations in cloud where you're charged a minimum of an hour's usage, even if you use 5 minutes.
Yeah.
So if your bursts turn a virtual machine on 3 times in an hour, you're paying for 3 hours as opposed to one machine going on and off 3 times.
Right.
So, again, a million different things to consider, and that's why we start off with the application assessment in order to be able to say, these are the requirements.
With all the vendors having different scales of how they offer costs.
So people might consider developing profiles, essentially, for the service that they're considering, and maybe you'll be getting to that. But the profiles might help them make those decisions, right?
Well, there's another there's architecture. Talk about the planning. understanding of upfront planning, understanding things that Barry's talked about in terms of really knowing your applications and your business case. Now, going from where you have a few people in your IT department to help you do move into the a data center. Now you go to self-service. So now you may have multiple people who are not really going through it every day. Now they have to be trained to do that. So what's the cost of that? And what's the cost of not doing something correctly? I had a personal experience about 3 years ago in Amazon. I thought I put some things in there and I thought I deleted them or shut it down. Well, 3 or 4 months later, I got these bills on my credit card, and I didn't shut everything down. But lucky for me, it was micro instances and didn't cost very much, and Amazon was very gracious and funded me. Because my point here is that because I didn't do it all the time, I didn't really understand how it really worked. I was being charged for something that I didn't want to be charged for. And so there's a cost associated with that, not having well-trained in the organization, thinking that they're going to save by going to the cloud, and they're not necessarily didn't do everything properly, and they're being charged for something. Like, leave your lights on when you're going to turn them off.
Yeah, all right. Barry Walter, can I have another question? Going back to your highlight of availability. Coming from the Department of Defense in the past, we've had critical mission areas that had to be 24/7 with absolutely no failure. So we would build COOP sites and we build mirroring data centers, those kinds of things. And I've not really heard a lot of talk about that in the cloud environment, but that's really available.
Okay. So, addressing a couple of things. First of all, Shelton's comment. One of the things that I'm not mentioned in this deck at all is the importance of a good management tool. Right. So, a cloud broker nowadays, you should be able to say, this is a test VM, I only want it available for the next couple of weeks, kill it off after that. Basically have a tool sitting there monitoring your cloud, right? If your utilization of certain virtual machines is near zero for a week, then prompt user, do you really need this anymore? With respect to the other comment, there are some enormous advantages in terms of not so much cloud, but certainly in terms of virtualization or fault tolerance. So VMware's product with their hypervisor, incredibly capable. It's actually possible to have 2 physical boxes running the same virtual machine at the same time, where any changes to the state of one virtual machine are copied to the other. So if one physical box goes down, the other one just keeps on running. Absolute zero downtime. Right? The networking will just carry on talking to the other virtual machine. I believe that would be incredibly difficult to achieve using physical hardware. And then, going back to the architecture comment, we tend to build our environments in such a way to make it as easy as possible to do disaster recovery. For example, making sure that you have templates that enable you to rebuild the virtual machines, and then keep all your data separate, replicate the data only. If you need to, you can replicate or rebuild the virtual machines. But as we go through the deck, the important things are, when it comes to the application, define what is your recovery point objective and your recovery time objective. Right? Once you understand those and you've got them written down, and they're realistic, right? Because let's face it, not every application is mission critical; it will be cost prohibitive. Once you know the requirements, then you can look at the virtualization set. You can go to the cloud or virtualization expert and say, these are my requirements. It's got to be 24/7. It's got to fail over to another physical facility that's more than 100 miles away. How do we design this solution? And it could be that with a private cloud solution, you could do it. You could possibly do it with public cloud. Again, it all comes down to getting the...
Yeah, I understand the private cloud, but I never understood the public.
Yeah. So, for example, some cloud providers set things up in terms of a region, and within that region, they have multiple availability zones. Right? In the DC region, I believe Amazon has 3 or 4 availability zones, possibly more. And virtual machines, you can have them replicate within a region, but across that availability zone. Replicating it across regions is also possible, but there's, again, more cost associated with that.
Thank you.
Any questions?
We're at 30 minutes.
Okay, never mind.
All right. So I've already talked a bit about CapEx versus OpEx. When you're talking about migration into a virtualization environment, there's a slow migration where you take a few physical boxes at a time, virtualize them, move the physical boxes, then take those physical boxes and kind of slowly roll your environment. And obviously that saves considerable capital expenditure on hardware. Not an issue if you just decide to go to the public cloud. Licensing costs is interesting. We've found that certain software vendors, if you run their application on a cloud, they want to charge you for every CPU core that the application could run on. So, which can work out absolutely astronomical. So, certainly something to consider there. The other thing is the cost of reputation. If the systems are down or if there's a security breach, what is that going to cost you? And then data requirements. I'll skip through these fairly quickly, but again, enterprise email, very high requirements, down the way to your expense system, much lower.
You know, you have to be careful about that. Just, for example, GSA's case, where they over email discovered that 10,000 was domino applications that would carry to you're still in the process of trying to do that.
Absolutely.
The cost savings out of the thing, fucking imagine that would be.
Right. And I think that's where it's important that your business users help with the application assessment. Because if this is done from an engineering perspective, your engineers are going to think, you know, tier 1 storage, tier 3 storage, and not understand the greater impact. HIPAA data is a great example, right? You've got an engineer thinking, yeah, I can virtualize this application, but what they don't realize is that the regulatory impact of putting that data onto a cloud is, you know, something that's too great a risk for most organizations today.
Security reasons.
Right. Yeah, right. So the final few other applications, obviously when you've got dependencies, so you know you've got your application, it's dependent on a database, you need to go through the whole application assessment for that database as well. What are its requirements? How many users and what are their usage patterns? Is it important that the application be scalable, or does it just work on a standard load? Are there high availability requirements? That's where we go back to your point about fault tolerance and disaster recovery. Greenfield versus brownfield updates, again, that kind of goes back to the fast versus slow migration problem. You know, which approach do you take? And then forklift updates, basically taking the entire application and running it into a new cloud by taking it offline and restarting it in the cloud, as opposed to, for example, moving the application servers, leaving the databases where they are, to move those. And again, whether you can do some of these things comes down to your latency and bandwidth. So, understanding the application. Security is not compliance. I get asked a lot about FedRAMP for typical organizations, commercial organizations. Not being compliant is effectively a risk of business. For the federal government, that's not such an option, right? You need to be compliant with these various regulations. The governance approach basically monitor everything, evaluate the situation, and fix any issues. And typically, there's organisations that will assess to ensure that you're compliant. But obviously, you need to make sure that it's even feasible to be compliant in the first place. So, for example, not putting HIPAA data into a publicly available place. And I'm going to skip this slide, but basically there's a number of different risks and mitigations to consider associated with those risks. And one of the things you see in almost all of these is a private cloud, because it is very similar to a traditional data center, but with a self-service component on top, tends to be a good solution for most organizations. And that goes back to your question about which cloud type do agencies most want to move to. The private infrastructure as a service cloud is very familiar, solves a lot of these problems. So now we've got the application, we've got the requirements, how are we actually going to work with it? There's multiple hypervisor types, there's multiple hypervisors, there's multiple cloud solutions, you've got your OpenStacks, your VMwares, and your Hyper-Vs. One interesting thing is the difference in licensing costs between all those. And not just the licensing costs of the virtualization layer, but also the licensing costs of the operating systems and applications that run on top of those. So all things to consider. Many organizations might benefit from actually using multiple hypervisors. And if you're going to go down that route, having a cloud broker sit on top to help manage all those is a very useful thing. But again, once you know your application's requirements, then you can decide, do I need things like high availability, fault tolerance, support for various peripherals, dynamic resource scheduling, moving virtual machines across different pieces of hardware. In terms of virtual storage, virtual machines have got very smart. They only use the bare minimum amount of storage that they actually need. As you write to, although your virtual machine might have a 100 gigabyte disk, as you write to it, it might, on disk, originally use 20 gigabytes, slowly increase up to 30 gigabytes using thin provisioning. So there's some advantages you can get there. Most virtualization platforms support multiple types of storage. You've got your block storage, which is really important for databases and file systems. And then you've got your file-based storage, which is useful when you want to share your data. There's also in the cloud object storage, which is a mechanism that applications often use nowadays. Allows you to put data into the cloud whereby it can be accessed by a URL, and again, that's an option for sharing of data across multiple users. And then
the same breath, people really haven't changed memory management. So, for example, your i86 box still can get itself clustered up, but you can't separate like you get big blocks.
Yeah, and there's a lot of things to consider, and if you go into something like a vSphere course on how to manage vSphere, they'll actually talk about how in order for your virtual machine to run efficiently, you've first of all got to have the resources in the virtual machine's operating system itself, and then you've got to have the resources available at the hypervisor, and then that hypervisor has to be able to get to the disk on the network quickly, and there's all these steps over and above what you had to worry about when you were dealing with physical devices. But the good news is that if the underlying infrastructure is set up correctly, if your virtual machine is running slowly because of CPU contention, you can tell the hypervisor, give this virtual machine some extra CPUs or give it some extra memory. And with the right operating system, it will see it's got more resources and run faster. So, something which in a physical environment meant someone powering the box off, plugging new chips into a motherboard, powering everything on again. So, again, there's a balance between the complexity of the environment and the flexibility that you get because of that. And in terms of networking, it's something more complex in a virtualization or cloud environment. You need to consider management networks for the hypervisor, networks to handle fault tolerance if you're going to literally be running two VMs and two separate servers, and their data from one is being replicated to the other. It's best to have its own network for that. Network for the VMs themselves, and network for access and storage. So lots of considerations there. Obviously, if you're working on a public cloud, something that the cloud service provider deals with on your behalf, but something that if you're looking at a private cloud, you need to consider. And then obviously applications, there's some segmentation of network traffic required. Typically you can do this with VLANs, and the hypervisor layer can contain switches that can help you separate your application traffic. So I'm going to very quickly look at some lessons learned here. Obviously the service model that you pick and the deployment model that you pick has a big impact on the types of issues that you're going to see. Infrastructure as a service, you're not going to typically see vendor lock-in problems because you've got a virtual machine. You can move it somewhere else relatively easy, whereas if you write your application to a particular platform, it's harder. And if all your emails exist in Gmail, it's almost impossible to get them out apart from just forwarding them to somewhere else one by one. So things to consider there. From a security perspective, and again, this is as applicable to public as it is private clouds. Integrity, you've got a lot more attack points. So whereas if you had a virtual machine running in your own physical data center, you can control the outside, you know who is running on virtual machines on the same physical box. You don't know that in public cloud. So putting controls in place to ensure that nothing gets changed without your knowledge is critical. Confidentiality as well, making sure that everything is encrypted. You're using VPN tunnels to get to your virtual machines.
On that issue, as far as the security is concerned, that to me, I think is one of the biggest bugaboos. All you need in terms of if you have an operation, Social Security or IRS or any one of those organizations, and there's a breach in the security, your level of trust in terms of the cloud just falls through the basement. How much assurance can you have in terms of working these issues to be able to assure somebody that security is not going to be breached?
Yeah, I mean, you raised the question in terms of cloud specifically. Target wasn't using a cloud and they got breached. So,
well, I understand. That's not to say that other non-cloud applications aren't attacked as well. But are you increasing your vulnerability in the cloud?
Yes and no. Right. So on the one hand, with a traditional physical data center, you have a whole bunch of compute. Over the lifetime of the data center, people have wheeled in new equipment, plugged it in and set it up. The people that did it may have installed the software differently. Right? I heard of a situation where if you upgraded Internet Explorer before applying a service pack, you've got a different vulnerability than if you installed the service pack and then Internet Explorer. So there's all these special cases in a traditional data center. With a cloud, you might have more attack points because you're sharing hardware. And again, this is public cloud, right? Not private cloud. But in a public cloud, you're sharing more stuff, so there might be more attack points. But with a cloud solution, you know exactly what hardware you've got, right? Because it appears on a website. you know that when you installed that virtual machine, it was based on this particular template and it has exactly the same vulnerabilities as all these other virtual machines. Everything's consistent. Everything is built using the same set of automated processes. So there's a level of assurance that you get from the fact that policies are more likely to be adhered to in a cloud environment than a traditional data center. And again, if your network is not set up properly and your systems aren't patched properly, you've got vulnerabilities on your systems. But the only real vulnerability that you have from a cloud or virtualization perspective that you don't have in a traditional data center is a hypervisor escape, where running on one virtual machine, you manage to do something that gets you control of the hypervisor that you're running on. Once you've got that, getting access to the other virtual machine. That's the only vulnerability that's really unique to cloud. Everything else, when you're talking about disk reuse, for example, you write a whole bunch of data to disk in cloud. Is that data going to be available to the next person who wants to use a disk? Right? Is that so much different from you write your data to a physical disk, and 6 months later that physical disk gets decommissioned and thrown in a skip outside. Someone picks it out, plugs it in, and I've heard stories about Disney movies being found on discs sold on eBay, those kinds of things. So my belief is that due to the automation and policy enforcement, cloud can actually be more secure than a traditional data center. Thank you. So we've talked about availability, designing your applications. So if you are in the position where you can redesign your applications to work in the cloud, you can increase your availability by orders of magnitude. Designing for loose coupling, taking advantage of some of the capabilities in some of the clouds, like the load balancing, elasticity, messaging, those kinds of things. If you write your applications to take advantage of those, you can increase your availability dramatically.
Yeah, well, I think, Barry, one of the things architecturally is, for example, on the DODAP side, where they have been implementing system engineering principles.
Okay.
And cloud, as you know now, is a variation of some of those same principles, and there's also some distinct opportunities to excel. Right. And so we've got that kind of discipline. In fact, something better should happen.
Right. And I often see cloud does for the data center what SOA did for traditional applications. Right. SOA said we take our applications, we break them apart, we offer little bits of services. It's easier to develop, it's easier to scale. And that's kind of what we're doing with cloud. We're taking a physical box, we're putting it into the cloud, it makes it easier to replicate it and scale it. And if we use the two approaches in parallel, we end up with more available, more elastic applications. Security considerations. So the lack of transparency in some clouds is a concern. I think most organizations that work with the federal government acknowledge that, and whereas NIST says that you really don't need to know where your resources are, typically cloud brokers that work with the federal government will say, yeah, this virtual machine is sitting in a box in Virginia or California. Hypervisor, we've already talked about escape, memory reuse. I think most hypervisors nowadays are pretty good about scrubbing memory that's been used by one virtual machine before it gets given to another. But again, it's possible. Gov clouds are popping up. I think Amazon has one and Microsoft has one. And basically, what they've done is said that only US persons can work in these facilities to meet the certain requirements for managing US government data. Dedicated instances is an interesting situation. So in some clouds, it's possible, although you don't have any visibility into the physical hardware, it is possible to say that I want all my virtual machines to run on the same physical box, that physical box only to be used for me. Again, there's costs associated with it, so it's all about if security is an issue, then that's a possibility. Obviously, operating systems, you've still got to do all your patching. And going back to costs of cloud resources, you want to consider the fact that when you get a virtual machine from a cloud provider, is it going to have your antivirus, your compliance management agents, and all the other bits and pieces that you typically put on a virtual machine in your data center, right? Because it may look really cheap on paper. By the time you've added the license costs for all the other stuff that you're going to put on it, you could have doubled the price just for the bare bones before you put the application on top. Lots of different types of storage introduce security considerations, including object storage. And one of the situations I saw is that clouds are starting to offer things like content delivery networks, where you have your data in one place, but the cloud will literally distribute it around the globe so that any user will get it from the closest possible place. And in order to do that, you have to have the right security set up in your original location for the content delivery network to get the data, and that can open up issues as well. A whole bunch of financial considerations. I think one critically, I could probably summarize this as each cloud provider has its sweet spot in terms of various capabilities, and pay for the right environment in order to meet your requirements. Don't forget the cost of networking, because it's not obvious when you purchase a virtual machine or sign up for one that when you're actually using it, if you copy a terabyte of data up onto that virtual machine, you can spend hundreds of thousands of dollars to do that, just to get the data. Actually, typically, it's getting it out of the cloud that costs you. Getting it into it is often free. But costs associated with networking are often hidden and expensive. And we've also found, going to Shelton's point, virtual disks, we've shut off virtual machines that have been configured to not automatically delete their disks, and you end up with all these disks that aren't connected to anything that are costing you money in storage costs. But again, a good broker will figure that out and either prevent it from happening in the first place or fix it for you afterwards. Lots to consider in terms of performance, but the reaction time when you're scaling, and particularly with this, you pay a minimum of an hour regardless. That's something to consider. Basically, do the due diligence on the environment to determine which cloud best meets your requirements. And going back to the application classification, right? If you want to run a big data job, a cloud which has fast storage and networking may be more beneficial to you than a cloud that has particularly good compute optimization. And finally, consider network latency when you're looking at separation of responsibility. So I've been on programs where one company was responsible for the VM images and another company was responsible for the cloud environment, and trying to get the two together working was a nightmare. It took months to get anything done. On the one hand, from a security perspective, it's a good thing to have that separation. From a getting things done, it can be difficult. Authentication when you're on virtual machines can be awkward. You need to make sure you have the right network set up, being able to hook into Active Directory. The end user interface is important. So are you going to use the interface provided by the cloud vendor? Are you going to have a service catalog type interface or a cloud broker type interface, and the capabilities that they offer in terms of protecting you from doing things like leaving disks available. Offering, so we've seen some environments, particularly where they're very strong on ITIL, where they'll offer 3 different types of pre-packaged VMs, small, medium, large, all running Windows. Pick one of those 3. A la carte option is where a user can go in and say, I really want 7 CPU cores and 6 gigabytes of memory and really obscure combinations. So what specifically are you going to offer there? Being able to measure the performance in the traditional data center and compare it with the cloud-based data center, so you get to see what issues in terms of costs, availability, performance, and finally, when you're looking at a public cloud provider, if they do fail, is there going to be some compensation? Are they going to help cover your losses, for example, having to bring up your environment in a different data center? So that's it for me. Any final questions?
Thank you, Barry.
Thank you. Barry, that was fantastic. Thanks so much.
Slides have already been posted to the Planning and Architecture SIG website. You do need to be logged in and a member of the SIG in order to access that site, and I'll be working with my colleagues to get it pushed to the public-facing, anonymously accessible knowledge bank as well.
Thank you, John, and thank you all on the phone for dialing in today. Look out for our next invitation for next month's speaker series, and we hope to hear from you soon. Thank you.
Can I ask one more question? Has Lockheed done any architectural modifications regarding documents and systems engineering types of things?
So Lockheed is a big company, but I tend to focus very much on the cloud broker solutions and cloud migration, and not so much at the application side of things. My guess is almost certainly some part of Lockheed looking at application re-architecting, but honestly, I don't know specifically about it.
Thanks, everyone.
Excellent. Thank you.